In this video, we will study RDT 3.0. In RDT 3.0, we are introducing two new issues and their solutions. One issue is the loss of packet or acknowledgement, and another issue is delayed packet or delayed acknowledgement. So far, we have considered the damaged packet or corrupted packet and for the corrupted acknowledgement. But this is that delayed packets or lost packets. All the previous versions of the RDTs handle checksum, sequence number, acknowledgement number, retransmission. All these things are as such available here also, as such implemented here also, but these are not solving the issue of delayed packet or delayed acknowledgement. For implementing this solution for this issue, we are using a time-based retransmission mechanism that requires a countdown timer. The approach of RDT 3.0 is, after sending a packet, the sender waits a reasonable amount of time for the acknowledgement. This reasonable amount is calculated experimentally, that based on the RDT or any other methods. Then, after waiting an amount of time, acknowledgement is not receiving. The sender thinks that the acknowledgement or packet is missed in between. So it retransmits the same packet. Actually, the packet is not lost. Suppose the packet is just delayed only. Then it will receive the packet with a delay. But the sender is unaware of this delay and senders start to retransmit the same packet when its timer is expired. So naturally there occurs a situation that the same packet may be received multiple times at the destination. So the duplicate packets are handled in previous versions also. It is handled with the help of sequence number. So the same technology is implemented here for avoiding the duplicates on the receiving side. This is the full explanation of RDT 3.0 with FSM. Here we have four different states: wait 0, wait for call 0 from above, wait for call 1 from above. Similar to that, wait for acknowledgement 0 and wait for acknowledgement 1. Let us consider the first positive scenario first. That is through this circular path. The system is waiting for the call from the above layer. Then it will invoke RDT send method. Then it will make the packet with 0. After sending the packet, then here we are introducing a timer concept, starting the timer. Similar to that, in the other case, wait for call 1 from above. There also the RDT sent. Then the packet 1 is created and it is sent. Then the timer is started. Then after the timer is started, the sender is waiting for the acknowledgement of the respective states. That is, after call 1, it is waiting for acknowledgement 1. After call of 0, wait for the acknowledgement 0. Sorry. So the acknowledgement 1 at this time, this is the positive scenario. Waiting for the acknowledgement 1, acknowledgement is received, and if it is not corrupted and if it is the expected acknowledgement also, that is, in this state it is waiting for acknowledgement 1 and the received acknowledgement is also 1. That is a positive scenario. At that time it will go to the next state. Before that the timer is stopped. That is, it is a positive scenario. Packet is sent, acknowledgement is properly arrived, stopping the timer, then again sending the next packet, waiting for the acknowledgement, and the acknowledgement is received properly. That is, acknowledgement is received, acknowledgement is not corrupted, and it is the expected acknowledgement also. That time timer stops and enter into the next stage. So this is the positive scenario. But in case of negative scenario, that is waiting for the acknowledgement 0. But the acknowledgement is timed out, that is it is waiting for acknowledgement, but acknowledgement is not receiving for a reasonable after a reasonable amount of time, still the acknowledgement is not received. At that time the same packet is sent and the timer is again started. The same scenario here also. Acknowledgement 1 is no longer arriving, it is waiting for a long period of time. Then the timer expires and the same packet is sent, again the timer is started for the next acknowledgement receipt. And these are the two negative scenarios. Another two negative scenarios, that is packet acknowledgement is received, but it is may be corrupted. Acknowledgement may be corrupted, or waiting for the acknowledgement 0, but it is receiving the acknowledgement 1. That is a negative scenario. At that time, it performs nothing and it is waiting for the positive acknowledgement or the expected acknowledgement. This will wait until it receives the acknowledgement 0. The same thing happens here also. Waiting for the acknowledgement 1, but the packet is received and acknowledgement is corrupted, or acknowledgement expected, it is receiving an acknowledgement which is not expected. If any of these two is happened, this is separated by or in the inside bracket, inner bracket. In both these cases, this is entering into a negative scenario. Here the RDT 3.0 receiving side is explained in another fashion, that is not with the help of FSM. Here we have 4 different stages or 4 different scenarios. That is, first one is if there is no loss of packet or acknowledgement, everything is going positively, nothing wrong here. That time packet 0 is sent, acknowledgement 0 is sent, packet 1 is sent, acknowledgement 1 is sent, and this is continuously done without any issues. Then another scenario is if a packet is lost, then how will it handle? The sender sends the packet 0, acknowledgement 0, that much it is positively going. Then the next packet is sent, but it is lost in between. So it is not at all received at the receiving side. But after sending, the sender is waiting for the acknowledgement, but it is timed out. So the sender assumes that the packet or acknowledgement, something is lost in between. So it has to resend the same packet. It do not know whether the packet is lost or acknowledgement is lost. So the same packet is sent once again because the timer is expired. Within the time period, the acknowledgement is not received. So the packet 1 is resent. Then the acknowledgement 1 is coming and continuously the same is repeatedly processing. The next scenario is if the acknowledgement is lost. So how will the system identify the loss of acknowledgement? So the sender sends the first packet, the acknowledgement is received, then next packet is sent. Here the acknowledgement is lost. In the previous case, the packet was lost. Here the acknowledgement is lost. So again, within the timer bound, the acknowledgement is not receiving. So the sender retransmits the packet. Actually, here the packet 1 is arrived safely. The same packet is receiving once again. That is, duplication of the packet is happening at the receiving side. This is handled with the help of sequence numbers, as in the case of previous versions. So this is what the case of acknowledgement lost. Another situation is premature timeout or delayed acknowledgement. Both are actually the same thing happens. one solution, that is for the same issue. These are dealing with the same issues. Here packet 0 is sent, acknowledgement 0 is received, then next packet is sent. Packet is actually sent, but acknowledgement is also sent, but the acknowledgement is delayed. Acknowledgement is not received at the reasonable amount of time. So the sender thinks that something happened to the acknowledgement, so it may be lost or it may be delayed. It is unaware of the sender, so the sender sends the same packet. Whenever the sender timeouts, it will resend the previous packet. So the packet 1 is again sending. But in the receiving side here, again the packet 1 is receiving 2 times. That is multiple time the same packet is received. So this will be handled by the receiver with the help of sequence number, as in the case of previous versions. Again, the remaining thing, acknowledgement is received. So acknowledgement is received with a delay. So the packet 0 is again sending, because acknowledgement 1 is received means the packet, next packet to be sent is the packet 0. So packet 0 is sending again. Then the previous acknowledgement 1 is received with delay. That is, acknowledgement 1 is received here once. The same acknowledgement is received once again. So acknowledgement is also received 2 times. So the packet 0 is repeatedly sending. So these two are handled with the help of the sequence number and the acknowledgement number. So this is how the delayed acknowledgement is handled. Now, what are the limitations of the stop and wait? Here we have seen all the RDTs are working under the concept of stop and wait, working in the same manner. That is, one packet is sent, it is waiting for the acknowledgement. Then after acknowledgement is received, the next packet is sent, and so on. So this type of algorithms or protocols are known as stop and wait protocols. The main advantage of stop and wait protocol is its accuracy, because once the packet is safely arrived at the destination, then only it will send the next packet. So we can guarantee the delivery of the packets. But this is inefficient because it will be very delay or a slow process while the transmission is happening. Another drawback is, because of this, the channel utilization will be very poor, because very less amount of data is moving through the channel. So channel utilization will be very poor. That is another drawback. Moreover, if two devices are distant, a lot of time is wasted for acknowledgement, that leads to increase in the total transmission time. As a solution to this waste of channel utilization and delayed transmission or slow transmission, we are moving on to another type of protocols known as pipelined protocols. Pipelining. Pipelining means the sender is continuously sending the packets without waiting for an acknowledgement. So there will be yet to be acknowledged packets in the channel. This figure explains the left hand side is the stop and wait protocol and right side is the pipelined protocols. Here the channel utilization is high because multiple packets, a lot of packets are moving in one direction and they are yet to be acknowledged. So in subsequent time delays, it will be acknowledged. The two major form of pipelined protocols are go back and selective repeat. These are the two concepts usually used for pipelined protocols. We will study these two in detail in the coming slides. Thank you.